All right, going to go over a few of these. This is your review for tomorrow's quiz. Make sure that you check your answers and you're ready to go. If you look at this top part, it says solve by taking square roots. What we're looking for here is the fact that we only have one variable, so I am able to get that variable by itself by using the inverse operations. Right, so the opposite of squaring would be taking a square root. So v should be the positive and negative value of the square root of 57. And so when we look at the square root of 57, are there any perfect square factors that go into 57? Nope. So that is our final answer. And so the same thing with question number 2. I only see one x. So to get x by itself, I got to go in the opposite order. So squaring comes after multiplying. I'm going to divide both sides by 10. So x squared should be equal to negative 60. And still, I don't have x by itself. So to get x by itself, I am going to take the square root of negative 60. X should be equal to the square root of negative 60. And the one thing I do want you guys to notice is when I do take a square root of a negative number, that's not possible. So we're going to wind up with this situation where we have no solutions. And we can't take the square root of a negative. Right, check your answers for the rest. If I look at the answers, the square number 3, and the square root of 27 has perfect square factor of 9. So plus or minus 3 times the square root of 3, where number 4, r equals positive or negative 5. Let's take a look at vertex 4. All right, when trying to solve in vertex form, I notice that there's only one x. So that means I can get that x by itself by subtracting 15 from both sides first. 83 minus 15 should be 68. Sorry for the technical difficulty. All right, so now 4 is getting multiplied to everything. So I want to divide everything I have by 4. And 68 divided by 4 should be 17. Still, I don't have x by itself. But x is being squared, so I can take the square root to get x minus 3 is equal to the square root of 17. I'm getting pretty close. I'm going to rewrite this up here so we can see it. X minus 3 is equal to the square root of 17. Right? There are no perfect square factors of 17, so I can leave it the same. Right? But to get x by itself, I'm going to add 3 to both sides. So x should equal the positive and negative square root of 17 plus 3. Remember, that's 2 answers. There's your solution. Right, so the same thing happens in number 6. Subtracting 3, the opposite. 1/2 is being multiplied, so I'm going to multiply by 2. Take the square root of 12. Positive negative 2 times the square root of 3. So when I subtract 5 should be my 2 solutions. Just remember how to solve by factoring. Zero product property tells me if I have 2 factors that multiply together to give me 0, both of these factors can be set equal to 0. And solving each, adding 3, 8x should be 3, divide by 8, x should be 3, 8's one solution. Subtract 5 on both sides. 4x is equal to negative 5. So if I divide by 4, x should be negative 5/4 solution. Right, number 8. This time I see that trinomial. Right, b squared. So our a value is 1. I can find 2 factors. What are the factors of 20 that add up to 9, 5, and 4? So b plus 5, b plus 4 should equal 0. Set factors equal to 0. B should be negative 5, 4, and negative 4. Cool. All right, check your work. Check out number 10. We are not equal to 0. So first things first, make sure we move that 2 to the other side. All right, number 10, once I did move, all right, I can factor and solve. Let's check out 11. When I see that that a value is not 1, is there anything that I can take out? All right, is there any greatest common factor to make factoring easier? I want to take out a 2. So I'm left with p squared minus 3p plus 2. All right, so now that my a value is 1, I can factor the factors of 2 that add up to negative 3. P minus 2, p minus 1 equals 0. All right, so remember, 2 does not equal 0. But p should be a positive 2, p should be a positive 1. All right, so the last one, same thing happens. Make sure we can factor out a 3 out of all terms, and then see your. All right, so as I see my work here in number 12, factor out a 3. My solution should be negative 6 and negative 2. Check out the next section. All right, the next section is just finding the discriminant. And once I find the discriminant, how many and what type of solutions? Right, remember, set equal to 0. A is 10. B is negative 3. C is 4. All right, b squared, negative 3 squared minus 4 a c. So 9 minus 4 times 10 is 40 times 4 is 160. So I notice 9 minus 60 should give me a negative number. It should be negative 151. Right? Since it's a negative, there are no solutions. Right? Negative numbers, no solutions. Right? Check out your work for the discriminant in the rest. All right, so as you can tell on 15 and 16, I did not have set equal to 0, so I have to make sure I put in standard form first, set it equal to 0. I get a positive discriminant, that means 2 real solutions. In 16, I have to do the same thing. Remember, I get a negative solutions or negative discriminant, so I get no solutions. Check out 17 and 18. All right, 17, put in standard form. Discriminant 64, so 2 real solutions. In 18, right, I decided to move that 4k squared to the other side of the equal sign. Made it easier, just 1 move instead of 2. The answer should wind up being the same. My discriminant, though, is 73, so once again, positive number, 2 real solutions. Make sure to pause this video to check your work. And solving with the quadratic formula, remember you get the quadratic formula on the quiz, negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so in 19, a is negative 4. There is no b. So B is 0 and C is 22. So I'm going to plug these values in. Negative 0 plus or minus the square root of 0 squared minus 4AC all over 2A. So 0 plus or minus the square root of 0. Negative 4 times negative 4 is positive 16. 16 times 22 should be 352, all divided by negative 8. I'm going to bring it down here and just simplify. 0 plus or minus the square root of 352 all over negative 8. All right, so I'm looking at the square root of 352. No, I don't. I know it's not a perfect square, but I'm thinking about perfect square factors. All right, so 352, if I look at it, can be divisible by 16. All right, so the square root of 16 is 4. So I have a positive or negative 4 times the square root of 22. There are no perfect square factors of 22, all over negative 8. And one thing I do want you guys to notice, right, I can reduce 4/8. That reduces to 1/2. So the square root of 22 over 2, so negative 2, should be our final answer. All right? Good luck.